Hi students, welcome to the ABK Chemistry channel. So today we are going to discuss about one of the important topic for your all board examinations as well as competitive examinations are also. So the name of the topic is elimination reactions. The name of the topic is elimination reactions. See, elimination reactions will be takes place generally. Elimination will be occurs in different functional groups. So now we are going to discuss about the elimination process in haloalkanes. The elimination process in haloalkanes we are going to discussing here. See, I am going to taking the example here. The example I am going to taking ethyl bromide. The molecular formula is CH3 and now CH2 and Br I am going to taking. The name of this compound is ethyl bromide. The name of this compound is ethyl bromide or bromoethane is IUPAC name you have to take here. See, in this compound, the halogen, which one is there? Bromine is there. The bromine attached carbon, what is there? That carbon is known as alpha carbon atom. The carbon which is directly bonded to alpha carbon, that carbon is known as a beta carbon here. The hydrogens which are directly bonded to alpha carbon, those hydrogens are known as alpha hydrogens. The hydrogens which are directly bonded to beta carbon are the beta hydrogens generally. So, in this compound, alpha carbon, beta carbon and 2 alpha hydrogen atoms, 3 beta hydrogen atoms are there. Alpha carbon atom, beta carbon atom, 2 alpha hydrogens, 3 beta hydrogen atoms are there. See, this compound can be treated with alcoholic potassium hydroxide. Alcoholic potassium hydroxide. See here, what is the how the elimination process will be occur in this compound? How the elimination process can be occur? See here, the bromine which is directly bonded to the halogen which is directly bonded to alpha carbon atom. From alpha carbon atom, the bromine will be eliminated. The halogen will be eliminated. Which halogen atom is there here? Bromine is there here. From alpha carbon atom, halogen will be eliminated. From beta carbon atom, hydrogen will be eliminated here. See, beta carbon has the 3 beta hydrogen atoms. Any one beta hydrogen will be eliminated. Any one beta hydrogen. In this, you take for example this hydrogen I am going to take it. Now the bond which is present between the carbon and beta hydrogen, this bond will be involve a double bond formation between carbon and hydrogen. As a result of this movement, and this will be eliminated from here, the hydrogen will be released from here. So what is the total compound we are getting here is nothing but now CH2 double bond CH2, CH2 double bond CH2, that is CH2 double bond CH2. Ethene we are getting. The name of this compound is ethene plus now here the bromine which is eliminated from alpha carbon atom, that bromine will be combined with potassium to eliminated as a potassium bromide plus the hydrogen which is eliminated from beta carbon atom, that hydrogen will be combined with OH group and now it will be eliminated as a H2. H and OH it will be eliminated as a H2. So this is the total reaction how it will be happening in the case of bromoethane. See here, for example, you take now the hydrogen atom will be eliminated from beta carbon atom and the bromine will be eliminated from alpha carbon atom. So here the hydrogen, beta hydrogen will be play an important role here. That's why this reaction is also known as a beta elimination reaction. Why beta hydrogen will be play an important role is nothing but, listen carefully 1 minute here. Now CH3, now CHBr, now CH3 I am going to taking here. The name of this compound is 1, 2, 3, 2-bromopropane I am going to taking here. 2-bromopropane. The name of this compound is 2-bromopropane. Now here, same process. The bromine attached carbon what is as there? That carbon is considered as a alpha carbon atom. The carbons which are directly bonded to alpha carbon, those carbon atoms will be considered as a beta carbon atom. Here only 1 alpha hydrogen atom is there. Total 6 beta hydrogen atoms are there here. Both beta carbon atoms will be contains the same number of hydrogens here. This beta carbon 3 hydrogens, this beta carbon is also 3 hydrogens. So this will be considered as a symmetrical molecule. Now from alpha carbon atom, which will be eliminated students, the halogen will be eliminated, that is bromine will be eliminated from alpha carbon atom. And the beta carbon atom, beta hydrogen will be eliminated. Both will be having same number of beta hydrogens. So the hydrogen will be eliminated from either of the beta carbon atom. No issue in that. So the reaction can be takes place in the presence of alcoholic potassium hydroxide. Now for example, I will eliminate the hydrogen atom from this beta carbon atom. Here there is a double bond can formation takes place. So what we are getting here, CH3, CH double bond CH2. The name of this compound is prop1ene. Of course, propene we are simply called. Plus what are the byproducts here? Now potassium bromide plus water we are getting here. So this is the process will be takes place here. But here up to this no problem. For example, I am going to taking here now CH3, CHBr and now CH2CH3, 2-bromo-butane. The name of this compound is 2-bromo-butane. 2-bromo-butane I am going to take here. Now here the halogen attached carbon atom is alpha carbon atom and this is the beta carbon and this is beta carbon. One alpha hydrogen is there. Now here we have the two different beta carbons. Why two different beta carbons? Now this beta carbon carrying the only two beta hydrogens. This beta carbon will be carrying three beta hydrogen atoms. Three beta hydrogen. Now in this case we have the two types of products. There is a chance here. Here how many types of products are chances? Two types of products. Now the reaction can be takes place in the presence of alcoholic potassium hydroxide. Here although the reaction can takes place in the presence of alcoholic potassium hydroxide. For example, first I am going to, for example, this way I am going to taking this is alpha dash, it is beta and it is beta dash I am going to taking here for example. First two, so when we have the two different beta hydrogen atom, two different beta carbons with a different number of beta hydrogens. This beta carbon 2 hydrogens, this beta carbons 3 hydrogens. Okay, when we have the two different beta carbons with two different number of beta hydrogen atoms, that time the name of the scientist is Saytzeff. The name of the scientist is Saytzeff. Sayzeff. Saytzeff. The scientist is also known as Zaitsev. The name of the scientist is Zaitsev. 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 So the name of the scientist is Saytzeff or Saytzeff, and what he suggested that when we have the two different beta carbon atoms with a different number of beta hydrogens, the beta carbon which has the less number of beta hydrogens, the beta carbon which has the less number of hydrogen atoms, from that beta carbon hydrogen is eliminated, we get a stable compound, that is major compound, and the beta carbon which has the more number of beta hydrogens, from that beta carbon hydrogen is eliminated, we get a minor product. For example, now from alpha carbon atom, which one is eliminated, students? Here bromine will be eliminated, and for example the hydrogen will be eliminated from this beta carbon. There is a double bond here. What we are getting here? Now CH3, CH double bond, CH3. The name of this compound is but2ene. The name of this compound is but2ene. 1, 2, 3, 4. Second position double bond is there. For example, the hydrogen will be eliminated from this beta carbon atom. Here there is a double bond we are getting here. So what compound we are getting here? CH2 double bond CH. Now CH2 CH3. The name of this compound is but1ene. The name of this compound is but1ene. Okay, so like that. See, now this is number 1, 2, 3, 4. The first position double bond is there, but1ene, like that. See, a Saytzeff or Zaitsev, he suggested that when we have the two different beta carbons with a different beta number of hydrogens, the beta carbon which has the less number of hydrogens, from that beta carbon hydrogen is eliminated, we get a major product. This product is a which product, students? Major product. And when the beta carbon which has the less number of or more number of hydrogens, from that beta carbon hydrogen is eliminated, we get a minor product. It is a minor product. See here, in the elimination process, the beta hydrogen will be play an important role. See here, from alpha hydrogen, halogen will be generally it will be eliminated. But the hydrogen and which hydrogen? Beta hydrogen will be play an important role. Hence, this process is also known as beta elimination. This process is also known as, what is the name of the process, students? Beta elimination process. Okay, so keep in mind, very very important, beta elimination. Now here I am writing here. Now the name of this process is, what is the name of the process, students? Beta elimination. At the same time, keep in your mind, students, From alpha carbon atom, halogen is eliminated. From beta carbon atom, hydrogen is eliminated. That means hydrogen, halogen, both can be eliminated. The elimination generally considered as a D. D is nothing but elimination. What are the elimination takes place? Hydrogen or halogen. So this process is also known as dehydrohalogenation. The name of this process is also known as, what is the name of the process? Dehydrohalogenation. Very important, students. Very important. So this is the total information about elimination process. See, can I again I am revising here, just listen carefully. If you take any one alkyl halide, the halogen attached carbon is alpha carbon. The hydrogen which are attached to alpha carbon, that is alpha hydrogens. Now beta carbon, which is directly bonded to alpha carbon, these are beta hydrogen atoms. Okay. Now from alpha carbon halogen, from beta carbon hydrogens will be eliminated. Hydrogen will be eliminated generally. The reaction can take place in the presence of alcoholic potassium hydroxide. The final products are alkenes. For example, ethyl bromide is involved in elimination reaction. We are getting ethene. In this process, now hydrogen, halogen both can be elimination takes place. This is also known as dehydrohalogenation. And the hydrogen will be eliminated from beta carbon. Why? It will play an important role here. Now see here, we have the two different beta hydrogens, but the beta carbon which has the less number of hydrogens, from that beta carbon hydrogen is eliminated, we get a major product. That's why the beta hydrogen will be play an important role. Hence this process will be considered as which process? Beta elimination process. Okay. Now when we have the two different beta carbon atoms with a different number of beta hydrogens, we get a major product when the hydrogen is eliminated from less number of hydrogens containing beta carbon. That was suggested by the Saytzeff or Zaitsev. Hence this elimination process is also. In this case only, keep in mind students, in this case only we are called which one? Saytzeff or Zaitsev's rule. And these two don't consider as a Saytzeff or Zaitsev's rule. These two. Why? Because these are symmetrical molecules, generally it will be eliminated. When we have the two different beta carbons with different number of beta hydrogens, that time only we are called Saytzeff's or Zaitsev's process. Okay, so keep in mind. So this is the total information about elimination process. Okay, thank you for watching this video, students. Please subscribe and like the channel, and at the same time please activate the notification bell icon for further information. Thank you for further updates. Thank you so much.